So, hello everyone, I welcome you all to this lecture. In this lecture, we are going to discuss another encoder, that is decimal to BCD. The full form of BCD is binary coded decimal. So you can recall that, let's say a number is written in decimal. In decimal, we use 10 symbols to represent any number. So we use only 10 symbols from 0 to 9. These symbols are allowed in decimal. All these symbols we convert in binary form. So let's say if there are 10 symbols, we require at least 4 bit to convert, right? So for an example, let's say if I take an example, if you have a number that is, let's say 945, this is in decimal, and if you convert into the BCD, so BCD, like individual digit, will be converted into binary. So 9 will be converted into binary. 9, when we convert into binary, it will take 4 bit, like 1 0 0 1. This is 9. 4 will be converted into binary, so first bit will be 0, then the next bit will be 1, then 0 0, so this is 4. Then 5 will be converted into binary, so 0 1 0 1, this is 5, and this is, you can say, it is the BCD representation of this decimal number, right? So this is decimal to BCD conversion. Now when we want to design an encoder for the same task, how we can do that? Let's draw the table for that. So let's say we are having 0 to 9 symbols, so we can quickly draw it like this. Okay, so let's assume these are the 0 to 9 I'm going to write here, and then the output. So let's say this is representing 9 9 8 7 6 5 4 3 2 1 and 0. Now we are converting into BCD. So in order to convert decimal into BCD, we require 4 bits. So those bits you can represent like either y3, y2, y1 or y0, or you can take it like, I will take like b2 or b3, then b2. So let me draw with same color like this. So this is one bit, then another, then another, and then one more. So these will be the output bits. So I'm writing b3, b2, b1 and b0. Now let's represent. So let's say if this bit is high, this is high. If this is high, then 0 will be represented in 4 bit with all 0. So this is 0, this is 0, this is 0, right? Now if so, like this, Okay, so let's say next time if we take this is high, 1 is high, and in 4 bit 1 will be represented as 0 0 0 0 1. If 2 is high, 2 will be represented in 4 bit like 0 0 1 0. If 3 is high, then in 4 bit 3 will be represented as 0 0 1 1. If 4 is high, it will be represented 0 1 0 0. If 5 is high, it will be represented as 0 1 0 1. If 6 is high, it will be represented as 0 1 1 0. If 7 is high, 7 will be represented as 0 1 1 1. If 8 is high, then 8 will be represented as 1 0 0 0. Similarly, if 9 is high, then it will be represented as 1 0 0 1, right? So this is the tabular representation, which you can easily understand. Rest of the places, those are blank. Assume these are 0 in this, right? So rest of the places are 0. Okay. Now when we write the equation for these B0, B1, B2, B3, so write, let's say for B3. So when we write it for B3, B3 is high here only at these two places, so it is 8 and 9. Then B2, B2 is high at these four places, so from 4 to 4, 5, 6, 7, right? So either 4 or 5 or 6 or 7. Then B1, B1 is high at these two and these two places. So these two places are 2, 3 and 6, 7. 2, 3, 6, 7. And B0, B0 is high alternatively. So it is 1 or 3 or 5 or 7, right? And last bit is 9, that is also right. So if we represent this thing, we will have 9 input lines, and then we can connect it, so there'll be 4 OR gate. So let's draw the circuit quickly. Okay, so now let's make the connections, and you assume that this is, let's say, B3, B2, B1 and B0. So when we start making the connection, look at the expression of B3, 8, 9. So B3, these lines are numbered as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So because B3 is having 8 or 9, the connection will establish with 8 like this. So we have with 8, and we can connect it with 9. Then the next is B2, 4, 5, 6, 7. So B2 can be connected with 4 like this, 5, 6 and then 7. Then B1, 2, 3, 6, 7. So B1 is 2, 2 is here, 3, 3 is here, 6, 6 is here, and 7 is here, right? And now B0 is all alternate from 1 to 9, so this is then 3, then 5, then 7, and then. So this is the circuit diagram for decimal to BCD encoder, right? With this I am ending this lecture. Thank you for connecting.